Okay, everybody. So today I'm going to show you how to solve this series, following series, where it's 1 over 1 times 2, 1 over 2 times 3, which is 1 over the denominator, which is the multiplication of two consecutive numbers up until 100, right? 1 over 1 times 2, 1 over 2 times 3, 1 over 3 times 4, right? Up until 1 over 99 times 100, right? So the instinct of most people when seeing long question where there's a lot of sum is they plug this into a calculator, right? However, this term has, well, almost like 99, 100 terms here, right? So even if you try to plug this into the calculator, it would take like 10, 15, 20 minutes, which is a long time. So that's what I'm going to do. What I'm going to do today is I'm going to show you how we can quickly, find the value of this series like similar to this, without having to find the value of each term individually, right? So most of the time in a long series like this, and a hard question like this, most of the time the terms will cancel out, right? Most of the term, like maybe this will cancel. Most of the term where there's maybe like just a easy two terms like m minus n, where you can just easily find the answer to this. So that's why I'm going to show you how to do this today. So first, when you look at this long sequence, you got to find a pattern, right? So you see, now we're going to try to find a pattern. Now you look at this. 1 over 1 times 2. 1 over 2 times 3. 1 over 3 times 4. Now, unlike most series, this series, instead of like, 1 over 1 times 2 or plus 1 over 3 times 4, like 1, 2, 3, 4 consecutive numbers. This series, some terms appear twice. In fact, most terms will appear twice in two different terms. Like look at this. 2 appear in term 1, term 2, 3, 4, and then up here until 99. 99 appear twice too. So, well, we can try to manipulate each term such that they will all cancel out. Most of them will cancel out. So, well, we got a very, very clever techniques, and I'm going to show you today. So now, if you've learned basic algebra, you've know how to recall that 1 over m minus 1 over n is equals to 1 over n minus m, n minus m over m times n. Basic algebra. So now you compare these two equation here. You see, the denominator is actually multiplication of two numbers, just like each term in this sequence, right? So now now look at this. It's not just any multiplication, a multiplication of any two terms. It's two consecutive numbers. You see, 1, 2, 3, 2, 3, 3, 4. So why don't we try to express this as some variable, like. So look at this. Why don't we express this as like m, and then m plus 1, right? Why don't we express it like that? So like it's the same with this. So we can express this as m plus 1, right? Why don't we try to express that? So it's the same with this. So we can manipulate like this, right? So now I'm going to do this. Let's replace n with m minus 1, right? So now it's the same with these. So now. So look at this, 1 over m minus 1 over m plus 1. You see here? Well, that's equals to m plus 1 minus m over m times m plus 1 equals 1 over m times m plus 1 times n plus 1. Right? So look at this. Compare these with any term here. It's quite literally the same thing. Like this, a term multiplied by a term after that, the numerator is 1, just like that, right? So now we can actually manipulate each term like this. So you see, let's take the first term, 1 over 1 times 2. You look at this. compare, it's the same, and this time m is equals to 1, right? And this is actually equals to this. So now we can plug this in, equals to 1 over 1 minus 1 over 1 plus 1, which is 2, right? And then we can do that the same with the second term. 1 over 2 times 3 equals, well, m equals 2. So it's, you know, you look at this and it's the same. So it's 1 over 2. And then 1 over 2 plus 1, which is 3. So it's minus 1 over 3, right? So you repeat the same until, well, you repeat the same until 1 over 99 times 100, it's equal to 1 over 99 minus 1 over 100, right? So now, let's set this equals a, right? Let's just set this equals to a. So now, the series a is actually equals to, well, 1 over 1 minus 1 over 2 plus 1 over 2 minus 1 over 3 plus 1 over 3 minus 1 over 4, and then plus until, well, then plus until minus, well, 1 over 99 plus 1 over 99 and minus 1 over 100, right? And now you look at this, these two terms cancel out, right? These two terms cancel out, and it's the same with all of these until, well, 99, because all of these terms from 2 to 99 appear in both terms. So of course, well, when you separate them like this, then we all cancel out. So this cancel until 99. But you look at this, 1 only appears once in the denominator, and then 100 only appears once. So it survives. So basically, this series a equals to minus 1 over 100, which, well, it's equal to 100 over 100 minus 1 over 100 equals to 99 over 100. Okay, well, that's how you solve this. And also disclaimer. Some people actually mistake the series with not series, which is 1 over 1 times 2 plus 1 over 3 times 4 plus 1 over 5 times 6. Well, it's not the same as this. So most people will try to, you know, implement this. Like when you use this technique, try to be careful. Like this type of series, well, there's a different technique to solve this. So disclaimer, don't try to use this in this type of series.
Yeah.